Some of the concepts, I believe, in this section will be familiar to at least some of you, but we'll introduce everything you need in order to solve problems and understand units in this class. Units are very important in solving problems. I don't know how many times I've had a student say, I can't get this problem to work out, and it's because of a unit problem. And so what I would encourage each of you to do is to develop good habits of problem solving where you carry the units along with you in solving the problem. And that will save you time down the line, even though it takes a little bit more time to write that kg down there for the mass. It'll save you effort and pain and anguish because you didn't detect a problem with the units. So there are three concepts in this section. And concept 2, 3, and 4. So conversions, you've seen these probably before in your chemistry or in other classes. Conversion factors, 1 foot is 0.3048 meters. Normally I'm not asking you to memorize any of these. In fact, in my class, you know exactly what you need to know, because what you need to know is in the actual concepts, the red box concepts. Anything outside of those concepts, you don't need to know. So, and you might say, well, why don't I just skip to the concepts and forget everything else in the PowerPoint presentation? And the answer is that the rest of the PowerPoint presentation is intended to help you understand those concepts deeply rather than just in a shallow way, in order to be able to solve problems. So, the world's highest waterfall. The highest waterfall in the world is Angel Falls in Venezuela with a total drop of 979 meters. That's a long distance, 979 meters. Express this drop in feet. We'll do a lot of unit conversions back and forth for different units. So this would be a conversion factor that you would be given, or you could look up in the textbook, or you'd be given on a test. For example, you wouldn't need to memorize a conversion factor. If you take this equality, that 3.281 feet equal 1 meter, then you can divide both sides of this equation by 1 meter. So 3.281 feet equals 1 meter. I'm going to divide both sides of this equation by 1 meter. The reason I'm carrying along these units here, the meter, is so that we can verify that we've done the calculation correct. Well, 1 over 1 is just 1. Meters divided by meters is just 1. Anything divided by itself is just 1, so the right-hand side just equals 1. So what this says is 3.281 feet over 1 meter equals 1. And that's what we've said right here. That's what we call a conversion factor. So if you have something that's expressed in meters, as you do in this particular case, 979 meters, and I want to convert it to feet, then I can certainly multiply this number by 1. And it won't change it. But the one that I'm going to multiply it by happens to look like this, 3.281 feet over 1 meter. This thing right here equals 1. So that's what we mean by conversion factor. You're actually just multiplying by 1, which allows you to convert the units. Well, now, have I put this conversion factor in correctly? And the answer is yes, because I can see that this meter cancels this meter, and I'm left with the unit of feet left over. So just do the multiply 979 by 3.281, and you get 3,212 feet. Reason you put the units in this conversion factor, if I had started off with feet and I want to convert with meters to meters, then these units wouldn't have canceled out, and I would have had to multiply by, instead of 3.281 feet over 1 meter, I'd had to multiply by 1 meter over 3.281 feet in order to get the units to cancel out. Another example, speed limit of 65 miles an hour in terms of meters per second. Well, you can look up a conversion on the internet. You can find a conversion of miles per hour to meters per second. But let's suppose that in a particular problem you don't have that particular unit conversion. So we're going to have to convert each thing individually. So what we do is we start out with the thing that we know. That's where we start. And we know we've got 65 miles per hour. Then we're going to multiply by 1 again and again and again in order to get the units to work out. This is 1. Because 5,280 feet equals 1 mile, 5,280 feet divided by 1 mile equals 1. So that's multiplying by 1. Why did I multiply by this conversion factor? Because this mile will cancel this mile. 1 hour equals 3,600 seconds. That's multiplying by 1 again. And this hour is going to cancel that hour. Then finally, I want to convert to the feet into meters. And so I've got 5,280 feet, so I'll need something in feet in the denominator, so the feet will cancel. Well, I've got the conversion factor right here, 3.281 feet in 1 meter, so I'll put the feet in the denominator, so these will cancel, and in the numerator I end up with meters. Now, having crossed out all of these units, let's see what's left over. I've got meters in the numerator and seconds in the denominator, so I should have an answer in meters per second. And then you multiply all the numbers, 65 times 5,280 divided by 3,600 divided by 3.281, and you get 29 meters per second, which we normally would abbreviate like that, because the notation for meter is just the lowercase m. Now, this is actually worthwhile kind of keeping in mind. We'll do a lot of problems involving speed, and speed will usually be measured in meters per second. And it's helpful to realize that about 30 meters per second, which is what we're talking about here, is about how fast the cars drive. The 65 miles an hour is about 30 meters per second. Distance from Vernal to Brigham City. Heber City is between Vernal and Brigham City. So here's Vernal, here's Heber, here's Brigham City. And Heber City is between those two. Vernal is 127 miles from Heber City. Perfect. And Brigham City is 166 kilometers from Heber City. How far is it from Vernal to Brigham City? And we've been given a conversion factor of 1.609 kilometers. All right, well, the distance is going to be from Vernal to Brigham City is 127 miles from Vernal to Heber, plus 166 kilometers from Heber to Brigham City. And you say, well, all I have to do is add those two numbers up. And I say, yeah, kinda. I mean, you can add 166 and 127, but then what units is the final answer going to be in? And the answer is it's not clear. So you can't just add 127 to 166 and say that it's something between miles and kilometers. It just doesn't work. So you've got to convert the kilometers to miles or the miles to kilometers first so that you can add two numbers with the same units in order to get a valid mathematical result. So let's convert kilometers to miles. We know that 1 mile is 1.609 kilometers. I've got kilometers in the numerator, so I know that I've got to have something with kilometers in the denominator. And that's this 1.609. So all the kilometers will then cancel, kilometers in the denominator, kilometers in the numerator, and then we'll end up with units of miles. So 166 divided by 1.609 will give me the distance between Heber and Brigham City measured in miles rather than kilometers. 166 over 1.609, add that number to 127 miles, and you get 230 miles. Okay, 4 rules. So this is a concept. We already had one other concept, which was the units of meters, kilograms, and seconds. This is another concept. Here's a hint. There's a red box that goes around it. That means that I'm expecting you to know it, and that it will be helpful to you in solving problems on the tests and on the MCAT or on whatever standardized test that you'll need to take at some point to test your knowledge of basic physics. So, state 4 rules for using units in calculations. So that, and I can't emphasize this one enough, to write down the units. I just graded some tests from the second semester, and I noticed several students were not following that advice, but I noticed that the stronger students in the class were following that advice, that they were writing down the units as they did the calculation so they can verify that the units of the answer are going to be correct. So I encourage you to develop strong habits of carrying the units along, and I'll give you many examples. So if it's a number and if it has a unit attached to it, then carry that unit along and write it down. Number 2, multiply by conversion factors to convert units, canceling units that appear both in the numerator and the denominator. I just gave you a couple of examples of that with the miles converted to kilometers, etc., or kilometers to miles. Add and subtract only those quantities with the same units. You can't add a distance in miles to a distance in kilometers. It just doesn't work, or at least doesn't give the correct answer. So make sure that when you're adding and subtracting something, 2 quantities that have the same units. You can't add something in kilograms to something that's measured in grams unless you convert the grams to kilograms or the kilograms to grams or whatever. Check your calculations by checking the units. So these are the basic standard good practices for using units in calculations. And these conversion factors, like I mentioned before, they're located in the page facing the inside cover of the book. And you could also just Google, and when you're working on a problem, you can't find a conversion factor, I just Google it. I say, convert miles to kilometers, and boom, the conversion factor comes up. But on a test where you don't have access to the internet, then I would give you those conversion factors if needed. Okay, which of the following statements concerning unit conversion is false? Units can be treated as algebraic quantities. That's true. In the examples we've done so far, we just put those units in, we treat them as if they're algebraic, as if they're numbers or symbols or whatever. You put them in. Units have no numerical significance, so 1 kilogram equals 1 slug. That is, that's not true. They do have, this is certainly not a true statement. Unit conversion factors are given inside the front cover of the text. That's certainly true. The fact that multiplying an equation by a factor of 1 does not change an equation is important in unit conversion. That's certainly true. You're just multiplying by 1 when you're converting these units. Only quantities with the same units can be added or subtracted. That's certainly true. So we've identified here that the units do have numerical significance. 1 kilogram does not equal 1 slug.